All right, I'm back. That was a little bit strange. It said I got a copyright. I might have violated a copyright thing. So I'm wondering if it's because of my puns used names or something. I have no clue. But hopefully that doesn't happen again. And if you did a copyright complaint, then bad. I don't know how I could have violated the terms of service. If you know what I did that might have violated the terms of service, please let me know because I want to avoid that. Okay. So we were talking about the basic circuit, which looks like this. And so I was answering a question about what I was asking a question about what would this resistor represent. And there's too many comments popping up here. I'm distracted reading all your comments. So that resistor might represent something like your house. Your house is basically a resistor from the perspective of the power company. A motor is basically a resistor from the perspective of the battery. A light bulb is basically a resistor. So it could be representative of something else, or it could literally just be a resistor. You can buy little electrical components. In fact, I'll show you what a resistor actually looks like. If I show you a resistor, oh, we can see pictures of them right here. So that's what a resistor actually looks like. So if you can go to the store and you can buy resistors. All right. So anyways, you're often going to see this rule written in a different form. You're often going to see it written as V equals I times R. Okay. So that's just taking both sides of this equation and multiplying by I. And you get V equals I times R. And so when you see the equation in this form, it's called Ohm's Law. And so that's a fundamental circuit thing. Is there anything with zero or infinite resistance? Very good question. There are insulators that have a very, very large resistance. Not infinite. Nothing has an infinite resistance. Is there anything with zero resistance? Yes, there is something with zero resistance, and it's called a superconductor. Okay. Superconductors have zero resistance. Okay, so if we use Ohm's law here, we have 12 volts is applied, and the current is unknown, and the resistance is 2 ohms. So we can take that and we can solve it very easily. We can divide both sides by 2. We can get that the current that flows in this circuit is 6 amps. And the current would flow out of the positive terminal of the battery. So it would flow in this sense. Okay? Wow, that's a really good pun, Charlotte. I like that. Okay. So if I flip this over, we're going to focus on resistors now for the rest of this lesson. So there are two fundamental ways to convert. All right, I think I'm back. Okay. I don't know what the deal is today. I'm wondering if I might restart my router. Okay, so it looks like the connection is fairly stable right now. So I'm just going to keep going and hope that I can get through it, and then I'll restart before the next lesson. So I was saying that two resistors in series is equivalent to a single resistor. There's a really nice formula for the total resistance. It's R sub S equals R1 plus R2. Okay, so for example, if you have, a 1 ohm resistor and a 5 ohm resistor in series, they are equivalent to a 6 ohm resistor. Okay. You can draw series resistors in different ways. So for example, that's two resistors in series. It just has a wire that bends. Okay. I also want to say that this formula extends to, in the obvious way, to more than two resistors. So if you have three resistors, the total resistance would just be R1 plus R2 plus R3. Okay? The second way of connecting two resistors is called a parallel connection. So a parallel connection is where you have a wire, and the wire branches into two parts, and then you have two resistors in each branch. Okay, and then the wire comes back together. So this is R1 and R2. And this is equivalent to a single resistor, which I'll call R sub P. And there's a really nice formula for R sub P as well. It's 1 over R sub P equals 1 over R1 plus 1 over R2. Okay. Let me show you some other ways that we could draw this. So we could have it drawn like this. You could draw parallel resistors like this. Okay. So there's all kinds of different ways of drawing parallel resistors. We could even draw 3 resistors in parallel. 3 resistors in parallel would look like this. So the wire splits into 3 and then it comes back together. Okay? The formula extends in the obvious way. So in this case, 1 over Rp equals 1 over R1 plus 1 over R2 plus 1 over R3. Okay? So that's parallel. What if we had a 1 ohm and a 1 ohm resistor in parallel? Okay? So we have 1 ohms and 1 ohms. What is that equivalent to? Well, if we use our formula, 1 over R sub P equals 1 over R1, which is equal to 1, plus 1 over R2, which is also equal to 1. So that's equal to 2. So that means that Rp equals 0.5 ohms. So this is equivalent to a single 0.5 ohm resistor. Okay? One thing that a lot of people forget to do is they forget to do the inverse of that. See how it's equal to 2, but that's 1 over R sub P. So you got to do the inverse of that at the very end. Okay? All right. So I think I'm going to do one example. I'm going to do that on a different piece of paper. And that'll be the end of today's lesson. So here's an example. Let's say we have a battery, and maybe it's a 24 volt battery. And so that battery is connected to a bunch of resistors. All right, something like this. Let me write in the resistance values: 2 ohms, 1 ohm, 3 ohms, 5 ohms, 5 ohms, 6 ohms, 10 ohms, 4 ohms, and 8 ohms. Okay, and so the question is, how much current is going to flow out of the battery? Okay, so what we want to do is we want to identify series and parallel resistor combinations, and then we want to reduce this down to just one resistor and one battery. Okay, so one of the things I noticed first of all is that these 2 resistors are in series. So I should add those 2 resistors together and get 3 ohms. Okay? Another thing you'll notice is that these 2 resistors are in series. So I should add those together and I get 12 ohms. Okay, for R sub S. These 2 are in parallel, so I should use the parallel combination rule. 1 over R sub P equals 1 over 5 plus 1 over 5 equals 2/5, which means that R sub P equals 2.5. A handy fact is that when you have two equal resistors in parallel, the total resistance is going to be half the resistance of each of them. When you put resistors in parallel, it reduces the resistance, and the reason why is because you're allowing two pathways for electric charge to flow. So it's two pathways. It's kind of like adding lanes on a freeway. If you have more lanes on the freeway, traffic can flow more easily. There's less resistance. Okay, so we're adding an extra lane for charge to go through. So it's going to reduce the resistance. So now what I'm going to do is I'm going to redraw the circuit. And when I redraw the circuit, I'm going to make all these replacements. So now that I've redrawn the circuit, you can see that these two were combined into a single thing. These two were combined into a single thing. Okay, and so on. So now what I can see is actually these three resistors are in parallel. So I'm going to use the parallel rule. So 1 over R sub P equals 1 over 6 plus 1 over 10 plus 1 over 12. Okay. And so I'm going to go ahead and do that on my calculator really fast. 1/6 plus 1/10 plus 1/12. So that equals 0.35, and then I have to remember to do the inverse of that. So I raise it to the -1 power, and so I get 2.9 ohms. Okay. Then you'll notice that these two are in series. So that says R sub S equals 5.5 ohms. All right. So now I'm going to redraw the circuit second to last time. Three ohms, 2.9 ohms, 5.5 ohms. So now all three of these are in series. So I can say R sub S equals 3 plus 2.9 plus 5.5. Equals 11.4 ohms. All right. So now I redraw the circuit. So we've got 24 volts and 11.4 ohms. So now I use Ohm's Law. V equals IR. And I've got 24 volts equals current times 11.4. So 24 divided by 11.4 is equal to 2.1 amps is flowing out of the battery. Going back to the original drawing here, 2.1 amps is the current that flows out of the battery. But you can see that much like a river, if you have a river that splits, it's like some of the water goes one way, some of the water goes the other way. So some of the current is going to go through each of these branches. So not every resistor in this circuit is going to get the 2.1. Okay, we'll talk more about that in a later lesson. So that's all I have for today. I apologize for the mishap that occurred, and hopefully that won't happen again. So have a good day, and I'll see you on Discord later. If you're going to do Discord, join the general voice chat, and that should be at around, I'm 10 minutes late, so that should probably be around, that'll be 3:40. So I'll see you at 3:40, I hope. Okay, bye.